So we were doing one question yesterday. Now we'll continue that degree 2 order 1 wala questions. Okay. Y equal to px plus p minus p square, where p is dy by dx. Solve it. How do we solve it? Try to understand. So what will I do is I will try to differentiate on both sides. If I differentiate on both sides, what will I get? Dy by dx equal to p into x ka derivative p plus x into p ka derivative dp by dx plus dp by dx minus 2p dp by dx. And dy by dx is p. So these two will get cut. We will get 0 equal to dp by dx common. Under we will get x plus 1 minus 2p. So either dp by dx is 0, where p is equal to constant, where dy by dx is equal to constant, y is kx plus c, or x plus 1 equal to 2p, where x plus 1 equal to 2 dy by dx. So 2 dy equal to x plus 1 into dx, and integrating on both sides, this is 2y equal to x square by 2 plus x plus c. Write it down for us. So I'll differentiate on both sides. Dy by dx equal to xp ka derivative p plus x into dp by dx, and 4 by p square derivative is minus 8 by p cube into dp by dx. Correct? Because this is 4 into p raised to minus 2, derivative is minus 8 into p raised to minus 3 into dp by dx. Is it clear? P and dy by dx are cancelled. 0 equal to x minus 8 by p cube into dp by dx. Now dp by dx can be 0, where p is constant. P is dy by dx, which is constant. Y का value मिल जाएगा kx plus c. Now on the other side, x is equal to 8 upon p cube, where p cube is 8 upon x, p is 8 upon x power 1 by 3. What is p, students? We know dy by dx is equal to 8 upon x power 1 by 3. dy equal to, sorry, 8 नहीं, 2 upon. Cube root लेना पड़ेगा ना, 8 का cube root is 2. Here also 2. So dy is 2x power minus 1 by 3 dx. Integrate on both sides. Y is equal to 2 times x power 2 by 3 upon 2 by 3 plus c. That's all. These are the two answers that are there. One is y equal to kx plus c. Another is y equal to 2x power 2 by 3 upon 2 by 3. 2 to cancel, actually 3x power 2 by 3. Is it clear, students?
Yes, sir.
Right. Now, y equal to xp plus square root of 1 plus p square, if p is dy by dx. This is the next question. So first, again, I'll differentiate dy by dx equal to UV rule p plus x dp by dx plus 1 by 2 root 1 plus p square into 2p into dp by dx. 2 to cut, p and dy by dx are cut. So 0 equal to, I can take dp by dx common. What will I get inside? X plus p upon root of 1 plus p square equal to 0. So we can again equate dp by dx is equal to 0. P equal to constant मिल जाएगा. P is dy by dx, which is constant. Y का value will be integration kx plus c मिल जाएगा. Correct? Dx cross multiply करो, integrate on both sides, kx plus c. From the other end, it is little difficult because x is minus p upon root of 1 plus p square. Square on both sides. X square is p square upon 1 plus p square. X square plus x square p square equal to p square. X p square common, x square minus 1 equal to minus x square. So p square is x square upon 1 minus x square. P आ जाएगा plus or minus x upon root of 1 minus x square. Now there are two possibilities, right? Plus or minus x. Now, depending upon the other integrals, we will try to understand this. dy by dx is this. Now dy equal to plus or minus x upon root of 1 minus x square into x. Integrated on both sides. Here we need half into 2. Correct? So y is equal to, see, denominator derivative is on the top. So half into plus minus root of 1 minus x square plus. That's all. Right.
There will be 2 also now.
Sorry, half will not be there. Plus minus. That's all. Because 2 root 1 minus x square will come. But half and 2 will get cancelled. Correct?
Yes.
Right. Matrices and determinants. Okay, actually both chapters are together. I'll teach you, I'll start with matrices, I'll teach you some part of matrices, then I'll teach you the entire determinants, then I'll teach you matrices. Actually, the concepts are mixed. Okay, so it's like together, consider them together. Now, nice and simple chapter. Mains में तो बहुत ही आसान questions आएंगे इससे. In advance, there are really good questions in matrices. In determinants, they are normal. Like you can solve them. It's not something which is impossible to solve or something like that. Okay, try to listen to all the concepts. It's completely new topic for you guys. So, what is a matrix? A matrix is an arrangement of elements. Now, what do I mean by arrangement of elements? So imagine 1, 2, 3, 4, -1, 0, 1, 2. This is an arrangement of elements. So if you ask me, sir, what is the relationship between these two numbers? Are they in multiplication? No. Are they in addition? No. Are they in subtraction? No. Then what is this? This is just an arrangement. Now, writing numbers in an arrangement, how does it help for us? Okay, that's what your question is, right? See, if in future, if you are going to take computer science, or if you already know some part of coding, in coding, you save things as a vectors, right? Information, the input, you save things as a vector or an arrangement of numbers, right? Imagine like you went to a just nearby home, like nearby your home, there is some shopping mart in which you bought some groceries. Now, every grocery cost is already inputted in that, correct, right? Now, let's say imagine 1 kg atta cost, 1 kg, let's say salt cost, they are input in that, right? In the groceries list. As an arrangement, they are arranged. Now, what does that cost of atta has to do with cost of salt? Nothing. They are just in data has been input in that system. Yes or no, students? Any doubt?
Yes, sir. No, sir.
Now, are they being, if you ask me, sir, are they being multiplied? Are they being added? No, they're just being kept at one location in an order. As soon as you scan that particular tag on that atta packet or a salt packet, the tag refers to a particular location in the drive, correct, right? In the memory. That location refers back this value, a number, into whatever is the weight of that particular thing, or number of, sometimes it is number of the packets that you bought. Imagine you bought 3 packets of atta. Then your cost will be what? Multiplying this with this will give you cost of the atta that you are purchasing. I'm giving you very crude example in which that arrangement of numbers happen in a system, right? Nothing perfect. Imagine you are writing a program. You are writing a program on people, okay? Imagine you are working for a company where you are writing a coding. And what coding you are doing is, you are doing coding of, you are writing a program to determine bonuses, yearly bonuses for a big company, okay? Think of it like this. There is a one big company which can't write its own programs. Let's say, imagine there's a pharma company which makes medicines and sells. In the entire USA, it is selling. Okay. Pharma company means it has a lot of thing, you understand, right? Lot of medicines being sold, a lot of employees will be there, which do all kinds of jobs except coding, right, students? So they will give this job to somebody else such that uske manager, us company ka like head of the entire company has to just run this coding by taking the inputs from the people and give them bonuses. Tell them, see this, I ran a computer program and program is telling you $2,000 is the yearly bonus and I have to give you. I'm giving you that only. So that nobody gets injustice. So in this, what are things that you need to take an input? How many hours he has worked, he or she has employee has worked? What is the benefit that they created? The department has created. By benefit, value that the department has created to the company. Well, of course, right? Some departments create a lot bigger value. So value of the department, his or her designation. Imagine they are some salespeople. They are going to sell the medicines. I'm not talking about in the medicine shops. I'm talking about they sell to medicine shops. Thinking to promote this particular medicine, reach new areas, new hospitals, and try to promote their own medicines. Yeah, I guess you understand, right? Like medicines are branded, like your t-shirts. All of you know this, right?
Yes, sir.
Yeah.
Yes.
Paracetamol is being sold by some 10 different companies. Okay. If you go to a generic medication shop, you will get some other one. If you get different medical shops, you will get different branded one of same paracetamol tablet. Okay. So think of it like you are replacing somebody else paracetamol with your paracetamol because you are a good sales guy. So of course he improved the sales compared to last year, this year, what sales they improved. So all these factors you are going to consider to give him a bonus, right? Yes or no?
Yes, sir.
Now,
Yes.
what has number of hours to do with amount of benefit? What is the formula you are going to apply? Initially, you are going to take the data, right, from each person. Yes or no? So you are going to ask them what data you need. For that, you will decide the final number. Is it clear? So this entire data is being saved as matrices. Now, when you multiply them, you don't individually multiply every number, right, using a calculator. You won't. This entire series will be referred to multiply or added or whatever is the factor that you do to with some other number such that you will finally reach the output. Is it clear, students?
Yes, sir.
Yes.
So that's what matrices are for. Like if you're, see, I just told you the crudest way of application, but there are lot many applications. Few of them we will study in JE curriculum only. But yeah, if in future, if you want to take up computer science or anything related to coding, please learn matrices, because knowing math behind the coding makes you the best coder ever. You need to know coding as well as knowing the math behind the coding also. Okay. Is it clear, students?
Yes.
Yes, sir.
Yes.
Listen to this. So matrices isn't just an arrangement of elements. Now we are going to study how do we, means what are the types of matrices, what are the arrangements that we can think of, what we can study out of it, so that we can use them. Is it clear? Now, as I told you, each thing is called an element, arrangement of elements. Okay, all these are elements. Clear? And horizontal things are called as rows. And vertical ones are called as columns. Okay, in fact, if I have to give you a number, this is first row, this is second row, this is first column, this is second column, this is third column, this is fourth column. Vertical ones are called as columns. Is it clear, students? Generally, when we read a matrices, we read from the row wise, not the column wise. We generally read row wise. Matrix is the what do you call it? Singular, plural is matrices. Okay, is the plural. Please write this part. I'll continue. Order of a matrix. What is order of a matrix? Sometimes when we want to mention, okay, the type of matrix, like before even give, we refer by order. We say we start by order. Okay. So order of a matrix is number of rows into number of columns. We don't actually do the multiplication. Okay. Don't do the multiplication. That leads us to confusions. We say as a 3x4 matrix or a 3x4 matrix. You can read it as 3x4 or 3x4 matrix. That means we have 3 rows and 4 columns. So 12 elements are there. Correct? Na? So just I'll write A1, A2, A3, B1, B2, B3, C1, C2, C3. Sorry, my mistake. 3 rows, right? 3 rows, 4 columns. 3 rows, 4 columns. A4, B4, C4. Correct, students? 3 rows are there and 4 columns are there. 1, 2, 3, 4. 4 columns are there. Any doubt, students? Number of rows into number of columns. This is the order of the matrix. So we call it 3x4 matrix or 3x4 matrix. You can read it any case. Is it clear, students?
Yes, sir.
Yes, sir.
Better. Now listen to this. See, every element has a number. See, generally, now if it, a matrix we write it in capital letters. Okay, name of the matrix we write in capital letters. So imagine a matrix is given like this. It is the symbolic form Aij. Let's say 2x4. Matlab, it's a 2x4 matrix, and Aij is the element. Okay, so Aij, when I'm writing this, remember it properly. This is the row number. This is the column number. So if I have to write it, first row, first column, 2 rows are there. Correct? Na? Second row, first column. First row, second column. First row, third column. First row, fourth column. Second row, second column. Second row, third column. Second row, fourth column. This is the matrix, students. So every element has a specific notation. We use it like this: A11, A12, A13, A14, A21, A22, A3, A23, A24. Is it clear?
Yes, sir.
Students, write it down. Find A3x4 equal to Aij if if Aij equal to 1 when I equal to j and I plus j when I not equal to j. Write on the matrix, students. Right. So A34 is what, students? That is equal to, we need to write 3 rows and 4 columns. Correct? Na? A11, A21, A31, A12, A13, A14, A22, A23, A24, A33, sorry, A32, A33, A34. what did I tell you? Aij is 1 if I equal to j. I equal to j वाला terms किधर है? ये तीनों I equal to j वाला terms है. Correct ना students? They are 1. So this is 1. Even here also it is 1. Even here also it is 1. Now A21 is what? Rest of them is, if I is not equal to j, it is I plus j. 2 plus 1. This is 3. 3 plus 1, 4. 1 plus 2, 3. 3 plus 2, 5. A1, 3. 4, 5, 1. Last column is 5, 6, 7. This is the matrix. Any doubt, students? Because Aij is mentioned, if I equal to j, तो 1 है. If I not equal to j, तो I plus j. So accordingly, we wrote it. Any doubt?
No.
No.
Right.
Sir,
Huh?
the horizontally it's rows and vertical is columns, right?
Correct. So number of rows is 3. 1, 2, 3.
Okay,
Number
sir.
of columns 4. 1, 2, 3, 4. Correct.
Okay, sir.
Clear?
Yes, sir.
Yes, sir.
First one. So next is types of matrices. You need to remember all of them, because when they give a type of matrix, let's say generally they start the question like this: a scalar matrix is doing this, or A is a scalar matrix, A is doing this, A into something is something. Now if you don't know what is scalar matrix, you don't know how to solve the question. That's it. So you need to remember the types of matrices as well. So the first one is a row matrix. A matrix with only one row is called as row matrix. Example, this is a row matrix. Next one, column matrix. A matrix with only one column is called as column matrix. Example, this is a column matrix. Next, third one, square matrix. A matrix whose number of rows is equal to number of columns. Such a matrix is called as square matrix. For example, 1, 2, 3, 4, 2 cross 2 matrix है 1, 2, 3, 0, 1, 0, -1, 2, 0. ये 3 cross 3 matrix है. 3 rows, 3 columns. Is it clear, students? This is square matrix. Number of rows should be equal to number of columns. Such a matrix is called a square matrix. Please write it down. Rectangular matrix. And unlike normal, every square is a rectangle wala thing, like this here, it is not like that. A matrix in which number of rows equal to number of columns. That is called as rectangular matrix. For example, sorry, is it not equal to? The matrix in which number of rows is not equal to number of columns is called as rectangular matrix. For example, 1, 2, 3, 4, 6, 7. This is a rectangular matrix. Is it clear, students?
Yes.
Yes, sir.
Next one, null matrix or a zero matrix. Null matrix or zero matrix. A matrix in which all elements are zero is called as a null matrix. They are null matrices. Please write it. Principal diagonal. What is the principal diagonal? Elements in a square matrix whose row number and column number is same. Okay. For example, ये वाला और ये वाला. If you look at them, so which are the principal diagonal elements? This entire elements are principal diagonal elements. This is A11. If you look at it, this is A12. Sorry, A22. So row number and column number should be same. Even here also, if you look at it, A11, this is A22, this is A33. Correct? Na? These three elements together, this entire element, we call it principal diagonal. The elements together. This is called as principal diagonal. Any doubt, students?
No,
Even here also. These elements are called as principal diagonal elements, and that is called as principal diagonal. Now, trace of a matrix. Okay. Sum of all elements in the principal diagonal of a square matrix is called its trace. Okay. So sum of these elements. Now imagine if A is 1, 0, 2, minus 1. What is trace of A? We write it like this. Trace of A, we write it like this. Here of A. Trace is sum of elements of the principal diagonal. That is 1 plus minus 1, 0. Is it clear, students?
yes, sir.
Students is properties of trace. There are a few properties of trace which you remember, which I wanted to remember. The first one, trace of A equal to trace of A transpose. What is A transpose? I will discuss. Okay. Don't worry as of now, and it will come in upcoming parts. Trace of A plus B equal to trace of B plus A equal to trace of A plus trace of B. Trace of AB equal to trace of BA. Now this is not trace of A into trace of B. Okay, don't write that. Trace of lambda A is lambda times trace of A. Lambda belongs to R. Fifth, trace of ABC equal to trace of BCA equal to trace of CAB. These are the things. Write down first. If A n cross n is IJ n cross n, That means it's a square matrix with n rows and n columns. Okay. Then what is trace of A? Trace of A is A11, A22, A33, A44, so on ANN. Or can I also write it as AII, where I equal to 1 to n? Any doubt, students? All the diagonal elements is the row number, column number, same. That is trace of A. Now, one thing I want to mention, if you have a square matrix, imagine you have a square matrix A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, A41, A42, A43, A44. I told you that this is principal diagonal, right? Yes or no, students?
Yes.
Yes.
Now, I'm telling you one more thing now. This particular thing is called as upper triangle. This particular thing is called as lower triangle. So, principal diagonal, this is called as upper triangle. All elements in that upper triangle. And this particular thing is called as lower triangle. All elements in that. Right now, students. Lower triangle matrix. A matrix in which all upper triangular elements or upper triangle elements are 0. 1, 0, 0, 3, 2, 0, minus 1, 1, 0. See, all upper triangle elements 0 is there. Such a matrix is called as lower triangle matrix. Upper triangle matrix. A matrix in which all lower triangle elements are 0. Okay. Example is 1, 2, 3, 0, 1, minus 1, 0, 0, 2. Such a matrix is called as upper triangle matrix. Here, diagonal matrix. Diagonal matrix. A matrix in which both upper triangle elements and lower triangle elements are 0. Okay. So a typical diagonal matrix will be like this: 1, 0, 0, 0, 2, 0, 0, 0, minus 3. This is a diagonal matrix. Is it clear, students? 1, 0, 0, 2. Students, clear?
Yes, sir.
Yes, sir.
End. Scalar matrix. A diagonal matrix in which all principal diagonal elements are equal. मतलब वैसा वाला. Both are scalar matrices. Now, the most important one, identity matrix, or we also call it as unit matrix. Unit matrix is a diagonal matrix again, a diagonal matrix in which all principal diagonal elements are 1. See, it behaves like 1 in matrices. Matrix multiplication में 1. See, generally multiplication में 1 कैसा behave करेगा? Any number into 1 is that number, right? Yes or no? 2 into 1 is 2, 3 into 1 is 2, like that. Matrices में this behaves like that. Is it clear, students?
Yes.
Right. Note. Two matrices are equal if each and every element of the matrices are same. Not even see. Imagine if you come and tell me, sir, मैंने 1 2 3 वैसा लिखा है, 1 2 3 वैसा लिखा है. Are they equal? No, they are not. Not at all. Okay, this is a row matrix, this is a column matrix. Even order is not same. Is it clear, students? Relative position same होना चाहिए. Clear? Imagine if I give you this is equal to some xyz. मतलब ये दोनों matrix is equal दिया है. This straightforwardly implies x must be 1, y must be 2, z must be 3. समझा students?
Yes.
Students समझा?
Yes, sir.
Next, another important thing to learn, transpose of the matrix. It is a matrix formed by interchanging rows with columns and columns with rows. So, for example, you have A is equal to 1 2 3 4 5 6. A transpose or A dash, you can write it anyways. I don't write it as A power T, okay? Don't read it as A power T. That is the worst way to read it ever. A transpose. A transpose or A bar is पहला कॉलम है, इधर पहला रो होगा. Second column will become second. Is it clear, students? The first column has become first row. Check it out. Right now, even second column has become second row. So if I tell you A is equal to Aij M cross N, A transpose will be equal to Aj N cross M. Right now, students?
Yes, sir.
What are the properties that we have for transpose? Even properties are important. First one, A plus B plus C whole transpose. That means when things are in addition, you can apply transpose to individual numbers. 2 matrices, 3 matrices, it doesn't matter. Second one, A transpose whole transpose is A. दो बार transpose apply करोगे, of course. पहले एक बार distort करेंगे, then again we distort means we'll get the same matrix back again. Third one, AB whole transpose is B transpose into A transpose. Fourth one, ABCD whole transpose is D transpose, C transpose, B transpose, A transpose, reverse order. And matrix multiplication is not commutative, not always. Okay. So lambda A whole transpose, lambda has no role, A transpose, where lambda is a scalar. Scalar matlab normal number, okay, not a matrix. Clear, students?
Yes.
Students,
Yes, sir.
write this down. Algebra of matrices. So first we'll discuss about addition and subtraction. Okay. In this, the first point, two matrices can be added or subtracted provided they are of same order. See, if they are not of same order, their number of rows and number of columns are not same, then we cannot add them or subtract them. Operation is not allowed yet at all. So how do we add them? Two matrices can be added or subtracted by adding or subtracting respective elements. Okay. For example, A equal to Aij m cross n and B equal to Bij m cross n. दोनों को order same है. So what will be A plus B? We just add both the elements Aij plus Bij respective elements only. मतलब A11 को आप 11 को ही add करना है, B1 को 1 को ही add करना है. Similarly, A minus B is Aij minus Bij m cross n. Is it clear? So if I have to show you an example will be, imagine you have 2, 3, 1, 7 and you are adding 1, 2, minus 1, 1. Then which one which will be adding? 2 and 1 we will add 3. Similarly, 3 and 2 we will add 5. 1 and minus 1, 0, 7 and 1, 8. Did you understand, students?
Yes, sir.
We will add the respective elements. Properties: A plus B equal to B plus A. What is the properties that we have? Is addition is as commutative as well as associative. And of course, I have given this A plus B whole transpose equal to A transpose plus B transpose. Correct, students? It's another property that we have. So addition is very easy. Like we just need to add the respective elements. There is no confusion, nothing. If in case the order is not same, then we cannot add them. Addition is not possible. Is it clear, students?
Yes.
Right now. Multiplication of matrices. Multiplication of matrices. So initially we will do scalar multiplication. Matlab, if I multiply, imagine you have a matrix A which is Aij m cross n, and आपको चाहिए lambda A where lambda is a real number. Okay, it can be imaginary also. Lambda is a scalar. Lambda is a scalar. Now that will be lambda times Aij m cross n. That means if I have to give you example, जैसा इमेजिन आपको 3 से मल्टीप्लाई करना है, 1 2 -1 4. सो 3 को हर एक एलिमेंट को मल्टीप्लाई करना चाहिए. 3 into 1, 3 into 2, 3 into -1. 3 into -1 is what students? -3. 3 into 4. सेम वे आपको कॉमन लेते वक्त भी you cannot take common from one particular element or one particular row or one particular column from a matrix. You have to multiply to each and every element. Is it clear, students?
Yes, sir.
Yes, sir.
Yes. That's all.